topology means how we are connecting the systems, in which manner, in which logical manner a network is connected. The end user or the laptop, end user means it will be laptop or it will be the system or it will be the mobile phone, whatever. What are the electronic devices connected to the network? That is called the end user. So how the end user are connected in a logical manner, that is called the network topology. So depending on the topology also, there are 5 to 6 categories are there. So we will go through one by one. And it is called like how we are arranging, it is called the network architecture. And I told the devices which are connected to the network is called the nodes. So we can tell what you mean by network topology means how the nodes are connected in your network is called the network topology. And the first one is the bus topology. In the bus topology, there will be a single cable. All the systems are connected parallelly to the particular cable. Okay, so singly disconnected cable, and all the nodes are connected as parallelly. This is what we discussed actually. And what will be the features then? The data will be transmitted through only one direction, and every device is connected to a single cable. And what will be the advantage? What will be the advantage? It will be cost effective because it is not no need that much connection, that much wires. Only one single cable only connected all the systems. So that much it is not the cost. And the cable required also, it is very less. In a single cable only we are connecting all the devices. And it is used for the small networks, and it is easy to understand, it is easy to connect, even it is easy to identify which system having the problem. So error correction also easy, and if any problem in the network, we can rework on that. So that was the advantage of bus topology. And what will be the disadvantages? If the main cable is having any issues, then what will happen? Complete our network will be damaged. So that will be the mistake. Okay, that can be happen if the cable having any problem. And even the traffic cable, all the nodes connected to the system is using the single cable, right? So what happens? So any traffic issues, if the traffic is more, it can be little delay. The baud rate will be late and it can be little delay. So that can be the disadvantage of this bus topology. And comparing to the other topology, it will be slower. Okay, this is what about the bus topology. Next, we will go to the next somewhat fast network topology, that is nothing but ring topology. So it is called the ring topology because you can see the arrangement of the systems or the nodes are connected as a connected way, right? So you can see here all the nodes are connected each other as a connected by not in a single cable, it is connected each other like that. So it is called a ring topology because it forms a ring as each commuter is connected to another commuter with least one connected to the first. Exactly. So in a particular system, they have only two neighbors, right? On left side will be there, on right side will be there. So like that, the manner if you are connecting, it is called the ring topology. And what will be the features of ring topologies? A number of repeaters are used for ring topology with large number of nodes. And because of someone wants to send some data to the last node of the ring topology with 100 nodes, then the data will have to pass through 99 nodes to reach the 100 node. Hence, to prevent data loss, repeaters are used in the network. The repeaters means like a simulation. It will just, if the bandwidth is less, we have to boost it. So for example, what the example it is telling, like I want to send a data to, I am connecting in a ring network, and my system, the first one is number 1. Okay, so I want to send the data to the 100, the last thing, or 98 or something. So this will be very far. So what the data I am sending, my signal will be after passing through this. So I am connecting first to the data has to go from first system to second to third, like that the way it has to convey. So if it is reaching the last, maybe there's a chance of data loss, okay, or bandwidth, so the signals will be with. So what we want in between, we want the boosters or repeaters. So the first feature of ring topology is if we want to connect or send the data to a long distance node, there will be a chance of data loss. So we want to use the repeaters in between the nodes. And the transmission is unidirectional, but it can be made bidirectional by having two connections between each network node. It is called dual ring technology. Okay, that's okay. So that means now see here that how the network is connected. Here is my first node, and I'm connected to the second node, and this will be the third node, and this will be fourth node, and this like that I connected. So it is actually a unidirection. That means data is passed from the first node to second node and 2 to 1. It won't come back. So 1 to 2, 2 to 3, like that it is going. That is called a unidirection. But if I want, I can make it as bidirectional by having two connections between each network node. That means I have to connect to, like this one wire I have to connect, and from here to here I have to connect. So now if you are seeing something, some diagrams in the network, you can see like this also. So it will be like this, I can connect. So it will be connecting, going the data both the direction. So ring topology is possible to work as bi-direction, but in the bus topology, I told we can go for only single direction, unidirection. But the ring topology, if you want, we can make it as dual ring topology by connecting two wires in between each node. And in dual ring topology, two rings networks are formed and data flow is in opposite direction in them. Also, if one ring fails, the second ring can be act as a backup to keep the network up. Okay, that means here, actually this node is connected like this, and actually the connection is, first ring is, for the first ring, see this like this it is going, right? This is the first ring. See, like this going, the first ring. And if the first ring having any issue, the second ring can be come up with the networks setup, because it will work as a backup. That is the advantage if I am connecting as a dual. Understood? So if normally the ring topology is single connection, if I want, we can go for the bi-direction by connecting also 1 to 2, then 2 to 1. So the data can be like two circle. So like this, the data will be passed as, see, like this one connection, and like this also one connection. So any one ring having an issue, second ring it will work as backup. But the problem is what? So now this connection is having some issue and it won't. So now another one, it will work, but it will work as from this direction, unidirection only it will work. But at least the backup will be there. Okay. Data is transferred in a sequential manner, that is bit by bit. And data transmitted has to pass through each node of the network till the destination node. Okay. That is a ring topology's features. Now, what will be the advantage? Means the transmitting network is not affected by high traffic or by adding more nodes, as only the nodes having tokens can transmit data. Means when I told about bus topology, I told there is only one single cable and all the nodes are connected here. That's a bus topology, right? So what happens if the traffic is more data is passing to the same cable? So there is a chances of network failure or data loss. But here, the traffic, it won't be affected because it is not like directly from the first node only going to the second node, like that only data is passing. So the traffic transmitting network is not affected by the high traffic by adding more nodes, as only the nodes having tokens can transmit the data. And it is not that much costly, it's cheap to install and expanding also not a matter. And what will be the disadvantage of the ring topology? Troubleshooting is difficult in ring topology. Troubleshooting means which all are connected each other. No, so which node having the problem is difficult to identify and to remove that one and connecting. See, for example, here in between on node number 1, 2, 3, 4, 5 and connected. We have a problem in third. Okay, first of all, identifying the particular node is difficult, and after that, removing both the connection left and right, then we have to add. So it is difficult for adding new network, new nodes in the particular network. And the failure of one computer disturb the whole network, right? So it is connected here. So first of all, it is difficult for us to identify which network having the problem. So for example, if this is failed, okay. So what happened? It will disturb. So if actually, if I want to pass from one to here, okay, if it is unique direction, it is a unidirectional network. I want to pass the data from 1 to 4. Actually, the third one having a damage. So complete network is affected. But previous in the bus topology, it won't affect it because it is parallelly connected. So node number 2 having a problem, it is not matter for node number 3 because data is passing, the data from 1 is passing to the cable and giving to here. Okay, it is not compulsory that before the node number 2 has to go. But here in the ring topology, from 1 to 2 coming, 2 to 3, 3 to 4 it is passing. So in between any one node affected is have a damage, means it will failure. The failure can happen complete, whole network having failure. Okay, that will be the disadvantage of ring topology. And next third topology, what is today is it is star topology. And as the architecture diagram you can see here, in this type of topology, all computers are connected to a single hub. So middle will be a hub. So it is avoiding the difficulty of previous one ring, right? Previously all are connected 1 to 2, 2 to 3, 3 to 4 like that. The data has to pass. Now it is not each other not connected. This node number 1 and 2 can't transmit data directly. Middle and person is there. Central control is there. One is passing data to hub. Okay, the central person. All are passing data. So, and if I want to go for 2, from 1 to hub it will come. From here it will go. Okay, one control is there, and that there will be a hub. That hub is connected to the single hub through this hub is central node, and all other nodes are connected to the central hub. Okay, hub is nothing but like a connector, also like a server. It will control all the things. Data will be stored in the hub and it will connect. And what will be the features of star topologies? Every node has its own connection, right? So like here, see, all the network node has, this is entirely for only for node 1 connection. Okay, it is not depending on, it is not connected to any other node connectors. So this is dedicated to only for the particular systems. Okay, so every node has its own dedicated connection to the hub. Hub acts as a repeater for the data flow. In this hub, hub will say like best topology, or I told them there we want some boosters to. Sorry, in the ring topology, I told there will be a repeater. We want to boost the signals. But in this case, we no need of any boosters because the hub will act as a booster also. So from the node 1, the data is coming to the hub, and this hub will transmit the data while it will be boosting also it will do. So no need of separate any boosters in between the networks. So every node has its own dedicated connection to the hub, and hub act as a repeaters for the data flow, and it can be used with twisted pair, optical fiber, or coaxial cable. So the cable can be twisted pair, optical fiber, and coaxial cable. And what will be the advantage of star topologies? It will be fast performance with few nodes and low network traffic. Why it is fast network? Because all have our own path. So it is not a problem. I have my own path to go from here to my home. So nobody is there. Okay, then I can come very fast, right? So one particular on node having a dedicated path, so it won't be any network traffic. That will be the advantage. And hub already I told it will work as a booster also. So that is also one advantage, and it is easy to troubleshoot, right? So all nodes are separately connected. So any node having a problem, we can easily find out the error, and it is very easy to remove the node and connect. That's troubleshooting, and error correction is easy. Connecting the new nodes also, it will be easy. And only that node is affected with that it is failed. Rest of the node can be work smoothly, right? It is not like a ring topology. I told ring in between one node will be damaged, complete network will be affected. But here in the case of this star topology, if one having a problem, no issue, remaining all will work smoothly. So next, what will be the disadvantage means, as you saw that there will be a hub. So surely the cost will be more, right? So the cost of installation is a little bit high. It is very expensive to use, And if the hub fail, what will happen? Complete network will be failed. Okay. If the hub fail, then the whole network is stopped because all the nodes depending on the hub. Performance is based on the hub, that is depending on its capacity. Okay, so while choosing the hub, it has to be, so that's why I'm telling it is expensive, because that person, the middle person, the hub has to be the capable of connecting all the networks and have to handle all the data. So if it is failed, the hub is failed, then complete network fail. But if a particular node fail, it is not affecting the complete network. So that will be the disadvantage of star topology. Okay. Next is our mesh topology. In the mesh topology, see like this, there won't be any hub or any central connection. All the networks are connected each other. Okay, all network is connected. So please understand the difference. There's a ring is one. This see like this. Okay, so 1, 2, 3, 4. Okay, so if I want to send the data from 1 to 3, I have to send the data through 2 only. 1 to 2, from 2 to 3 will come. I can't directly I can't transfer data from 1 to 3. Okay, this is a star. So that's why I told there one, this is fail means complete network will be fail. But in the case of mesh, all the nodes are connected each other. That means node number 1 is connected to 2, connected to 3, connected to 4. Node number 2 is connected to 1, 3, 4. So all the nodes are connected each other through the wires. That is a mesh. Without any hub, directly it is connected, is called the mesh network topology. So it is a point to connect to other nodes or devices. All the network's nodes are connected to each other, and mesh have n into n minus 1 by 2 physical channels to link n devices. Right. There are two techniques to transmit data over the mesh topology. They are routing and flooding. So two type of techniques we are using for connecting the data into the in this mesh topology. They are routing and flooding. Okay, we'll come to the we'll see what is the routing. So in the routing, the nodes have a routing logic as per the network requirement, like routing logic to direct the data to reach the destination using the shortest distance, or routing logic which has information about the broken links and avoid those nodes, etc. And we can even having routing logic and reconfigure the failed nodes. Okay, so routing in the sense I will tell you, and means I will draw here. This mesh topology I will draw. Okay. Okay, so all the nodes are connected, but I want to see 1, 2, 3, 4, 5. Okay, so I want to send the data from 1 to 4. So there are so many connections are there. I can directly send 1 to 4. I can send, okay, or I can pass 1 to 2. From 2 to 4 I can go, or I can pass 1 to 3, then 3 to 4 I can come, right? So so many ways are there to connect the data or transfer data. So this time, how the network will how it will identify, or how it will decide which route I have to go. Okay, that is called for that we have the routing algorithms. And what it will do, it will find out the shortest distance. Okay, shortest distance. It can be more. No, maybe you are thinking, okay, it will be, how come this 1 to 4 only the easy way? Maybe you will think, right? So it is not like that. I will tell you here in this diagram. Okay, no. See, I want to send from here to here. Okay. So in that we are using two technology at all, that is routing technology and flooding technology. In the routing technology, see here to here it is 2. Okay, the distance will be 2. From here to here it will be 1. From here to here I have the distance 5. Okay. Okay. So node number 1 is node number 3. Okay. There is a distance between the nodes. Children, please see here. Node number 1 to 2, the distance is 2. Node number 2 to 3, 1. Just I written for your understanding. 3 to 4, 8. And 4 to 1, 6. And everywhere I written. So now I want to send data from node number 1 to node number 3. Okay. I want to send a data from 1 to 3. Which are the paths are there? See, I can send two way. I can send 1 to 2 and 2 to 3. Okay. I can send like this. This is the first method. I can send the data from 1 to 2 and 2 to 3. What will be the total distance? 1 to 2 is 2 plus 2 to 3 will be 1. So that means 3. So I want to send the data that the distance is 3. Another way is there. I can send from this first. Children all are listening, I hope so. The second method, I can send 1 to 4. 1 to 4 is 6 plus 6 from here 4 to 3 I can send. So 6 plus 8, right? So how much it will be? 14. Okay. The next way I can send from 1 to 3 directly. 1 to 3 directly if I am sending, it will be 5. Okay. Then what is the other methods? This much only, right? So in that, like that, all this distance you are calculating, and from the distance which will be the smallest distance, that way I am connecting. Understood? So in the mesh technology, network topology, all the networks are connected, but it is not like meaning, okay, if I want to send 1 to 4 directly, that connection only I would not like that. It will see all the possible connection things, and from that, which is the smallest one, which is the easy way I can reach, that it will select. So in this, how I can 1 to 3, if I want to send data, it is better I have to go for this part, 1 to 2, 2 to 3. That means 2 plus 1, 3. So this will be the shortest distance. So who will find out these? Who will know? Who will calculate? For that we have the routing algorithm. Clear? So for the mesh internet connection networks, there we can send all the nodes are connected each other. But still, if I want to send a data from one node to another, we can't easily find out which node has to go. For that, we have the mechanical techniques we are using. That is the routing technology and flooding. Okay, the routing is nothing. So we will see all the distance and which will be the shortest distance, that we will find out, and in that way we will take the data for that. That is called the routing. This was written here. Please. Okay, that was here written routing. In the routing, what your sentence, maybe it is a little difficult for you to understand. That's why I explained you, right? So there will be all the network, all the systems, all the nodes are connected. But for sending a data, we will always check out which will be the shortest distance. So this is deciding by the routing algorithm. There are so many routing algorithms. We will go to that. From that algorithm, we will find out the shortest distance. Okay. Why it is doing like this? Because to avoid the distance and avoid the timings, very fastly we can go through if it is very shortest network. Okay. So next, another one is there, the flooding. Flooding means the same thing, it is connected and it won't see the particular shortest distance. What it will see, I have like in Google Map, if I want to go from here to Elanga. Okay, so from the Google Map, I can see, I will come to know there is traffic or not. Okay, so if I will come to know from the Google Map, okay, this road is traffic, then I will think, okay, I can go for that, another road. Okay, so actually the distance will be less. From here to, I can go Narayanapura, the bridge, and from there, direct way I can go. But from this, I will come to know, okay, the signal, that is the shortest distance, but still that the traffic is more in the road. Okay, some problem or some accident is there the road. So what I will do, I will select another road. The traffic will be more, no, distance will be more, but traffic will be less. Okay, that is called the flooding techniques. So all the networks are connected and each having a particular connection, everything is there. And I can come to know the shortest distance also, but that particular moment the traffic is more in the particular connection, then I will select the another one. That is called the flooding techniques. So routing and flooding techniques are used in the mesh topology for transmitting data. Okay, I think it is clear. And what will be the advantages of mesh topology? It will be robust. That means it won't be delay, or I can't tell it is data is not sent and it will be robust, and fault tolerance or fault finding is very easy, and it provides security and privacy. Why? Because I have a particular channel for myself, so it will be surely it will be secure. In the bus and all, what happening? The same cable all are using, so it won't be that much security. But in the mesh topology, the security is more, even the privacy, because I have a particular dedicated channel for me. Okay. And what will be the disadvantage? Like previously, cost will be more because all are connected. In the bus, only single cable connected all the network. So less the number of cable I require. But here what happening? All are connected each other. So many cables I want. So surely the cost will be more. And the installing and configuration also, it is difficult. All are interconnected. That's why. So these are the two disadvantages of the mesh topology. And next coming is the tree topology. The tree topology means like a level wise I will arrange. So here the top there will be a node, and from this you can see a left and right nodes. Okay, there will be left and right, and from here again connected to, okay, and from here again it is two, like this. Okay, like this connection. So that is called the tree topology. So what are there will be a first node, no, that is called the root node here. Okay. Okay, this is called the root. See, this one is the root node. So there will be a first and root node. From the root node, all the nodes are connected as a levels. So to avoid previous problems. So that means previously in the mesh, it is all interconnected. The problem is what? It is very costly, and it is fault tolerance is difficult, I told. But here, what happened? It is like a level wise. So level wise means fault tolerance is very easy, right? So then there will be a first central root node, and all the nodes are connected through the root node. It is as a hierarchical topology. It should be. It should at least have 3 levels to the hierarchy. See, this is a level 0, level 1, level 2, or like otherwise it can start from first level 1, 2, 3. Okay, this is the levels. Level come from the top. Okay, levels, if you are asking the levels, don't tell this is a level 1, level 2, level 3. Level has to start from the root node. So that will be level 1 or level 0, then level 1, level 2, like that. Okay. So this is the type of architecture is called the tree. So what will be the features of tree topologies are? It is ideal if workstations are located in groups and used in wide area network. In the WAN connection, we are using always the tree topology. And the advantage is extension of bus and it is an extension of bus and star topology. The advantage of bus topology and star topology is reflecting in the tree topology also. And expansion of nodes is possible and very easy, and error detection and is very easily. And the disadvantage is if more nodes are added, maintenance will be difficult. And central hub fail. That means my root node is failed. It will be completely failed. The network will be completely failed. Okay, that's about the tree topology. And next is the last one is the hybrid topology. Hybrid means, see, you can see it is a mixture of ring and ring, correct? Can you see? This is a mixture of ring topology and star topology. It is using all the properties of ring topology, star topology. It has two different type of topology. It's a mixture of 2 or more topologies. So now we can see here, it is like a best topology also you can see, right? Because there's a center cable. In the center cable only all nodes are connected. So it is we can tell it is a combination of a best topology. And here you can see like there will be a central hub, and in the hub it is connected, right? So that also you can see, and sometimes it can be see as a star topology. So it will be a mixture of any two topologies called a hybrid topology. Okay. So for example, if in an office, in one department, ring topology is used, and in another star topology used connected, this topology will result in a hybrid topology. Okay, so which are the two topology we want to select is the network admin wish. So it will be a combination of two or more topologies called the hybrid topology. In the, for what example I told, in a department, say, we three admins are there. So the admin systems I can connect as a bus. Okay, and I have a team. In my team there are 6 people working. So in that time I can work it as a T topology because I am the admin, and under me there are 6 people working. So that's 6. So me and my 6 people are working as a tree topology, and me and my same other team captain who is working as a bus topology manner. Okay, so all together we can tell it is a hybrid topology. So it is a combination of two or more topology depending on the network what I am using in my particular organization or institute is called the hybrid topology. Okay, so what will be the advantage of this hybrid topology? We can utilize all the features, good features or advantages of all the topology, and no, so it will be easy for us to identify the mistake and fault tolerance and connecting all the nodes. So that will be the easy. So these are the 5 topology what we look today. Okay, hope you all understood, right?